Hello everyone, this is Mr. Geringer again, and this is 7.5, the shortest networks for 4 more points. So last chapter we learned about the Steiner point. If you recall, the Steiner point is that point that's in the center of 3 points. If we were able to leave the graph, the Steiner point represents the most optimal network. If we couldn't leave the graph, then of course, for example, if the angle was bigger than 120 degrees, or if we just decide that based on our business need, our real life need, that we could not stray from the model, then the minimal spanning tree is what gives us the optimal solution. So the Steiner point relies on 3 points. So we're going to look at what happens when you have more than 3 points. So let's look at this example. Basically, we've added another city from the previous chapter's example. We've got A, B, C, and D. Each edge or each link is worth 500 miles. So what do you think the optimal network looks like for this guy? Well, we could do minimal spanning tree, which is we go from C, let's say we go from D to A to B to C. So we could do this. That's going to result in a mileage of 1,500. But if we could leave the graph, then we could do something like this. We could get a junction point and we could pull in to the very center, much like we did with the Steiner point. We just go directly to the center. We connect them all that way. It makes the links shorter, and so now we come to 1,400 miles. But I'm here to tell you that the Steiner point still works. So look at these graphs D and E. We created a Steiner point that would be the center of a triangle if a triangle existed. If we made, again, a Steiner point with 120 degrees in each angle, B and A connects to the Steiner point until we get an angle that's 120 up here at the top. And then we just draw a line this way to connect the other Steiner point that we did exactly the same. Then we will actually find the minimal spanning tree. So this figure here, the rule still applies, as a Steiner point provides you with the most optimal network. Of course, you got to be kind of creative on how you use it. If we were to measure this, it would measure out to approximately 1,300 miles. So we were able to beat the 14 and the 15 simply by using the Steiner point. Now don't worry, in this class I don't make you compute what these actually are. You just have to recognize them. Recognize that this Steiner point is a lot cheaper than just going directly to the middle, even though I didn't on that graph. Man, I suck at drawing. Anyway, so the only possible interior junction points are the Steiner points. Those are the ones that if you could leave the graph, then you can come up with the optimal. We're going to call this the interior junction rule for shortest networks. So just to recap, minimum spanning tree. If you were looking for the shortest network, you have 2 choices. You could either go the minimum spanning tree, which has no interior junction points. It's all on the graph that you created. Or you could do a Steiner tree. So a Steiner tree is going to be something that is created based on leaving the original graph. It does have interior junction points. And this is the end of that quick chapter. Yay!